about dimensional analysis. For that, we should know why it is required. Dimensional analysis is required because it actually helps you to understand all the physical quantities, how you can represent them to a basic three quantities, that is mass, length, and time. Or another two fundamental quantities are there, temperature and charge. So let's go to next slide. First, we should know what is dimensional analysis. It is basically simplify all the physical problem with respect to using certain dimensional homogeneity to reduce the number of relevant variables which will govern or which is actually govern the physical phenomena or physical process of a system. What does mean? What is dimensional homogeneity? If there is a equation and the left hand side and right hand side of the equation, if you go for reduction in dimension to a basic dimension like primary dimension, what I have written here, mass, length, time, temperature, and charge. And though if you represent any physical variable or physical quantity to those primary dimension, and if you see the power of primary dimension in the left side of the equation and right side of the equation are same, then you can tell that you have reached dimensional homogeneity kind of things. And then you have to understand what is dimension in order to understand overall dimensional analysis. Dimension is basically a measure of physical quantity. There are different ways of processing dimension system. One is MLT system, that is mass, length, and time. Another is FLT system, force, length, and time. Generally, general thought is that we are used to stick on the MLT system. Sometimes some very dynamic system we used to talk about force, because force is not a fundamental force. You can represent by ml t to the power minus 2, mass into acceleration. In the mass dimension of mass m, acceleration dimension is L t to the power minus 2. So in this way, force can be represented by ml t to the power minus 2. So you can tell that FLT system can be represented by actually MLT system. But for the purpose of dynamic system representation simplification, we used to do this kind of thing. And now we are going to understand actual what is the methodical approach for the dimensional analysis. It is a systematic procedure of identifying the variables in a physical phenomena, and we want to correlate them in a set of dimensionless group. Dimensionless means if the ratio of two quantities, and if you go for the fundamental or primary dimension, then it becomes a dimensionless. Cancel out all the dimension by denominator and numerator. In this way, if you can represent the system, then dimensional analysis, you can tell that this is a dimensional analysis process. So in order to understand overall dimensional analysis, these are the three things also you have to understand. For already I discussed about dimensional homogeneity. What is that? Every term in an equation when reduced to fundamental dimension, MLT, FLT, it must contain identical parts of each dimension. Means all the two sides of the equation and each term, if the each term of the equation is represented by adding or something other operation, though all the terms should have identical power of each dimension. Then only you can reach dimensional homogeneity. And next thing is dimensionless number. Quantities that do not have dimension, like a number 2 or theta angle, does not have any dimensions. In this way, if you can understand, then it is a dimensionless numbers, and other dimensional numbers later on we will understand. And non-dimensionalization is important because you want to make system characteristics independent of its size, shape, and all those things. To understand those kind of scenario independent of size and shape, you should go for non-dimensionalization process. Removal of units from physical quantities by suitable the substitution of variables, because you have to substitute the variable by suitable substance of MLT configuration. So in order to do that, you have to remove the units. And how to remove the units? Only when you will get no dimension overally, after the getting the ratios of numerator and denominator, you can non-dimensionalize the thing. So in this way, you can tell that unit can be removable by certain suitable substitution of different variables. So now we have to understand what is dimensional and what is non-dimensional. So suppose you are having a dimensional equation, so you will find that z equal to z0 v0 t half gt square. This is a very fundamental equation of Newton's laws of motions. So here z0 is initial distance or initial height, whatever you can tell, and v0 is the initial velocity, and the time t, and half gt square is a representing g is a gravitational acceleration. So if you see this equation, there is a 5 variables and all the variables having a dimension. So these kind of things you can tell that is a dimensional equation. You have to get certain dimension in the form of MLT or in the form of FLT. So in this way you have to stick to certain dimensions. So you can tell that dimensional equations, there is at least one variable will be there throughout the equations, and that variable dimension end of the equation you have to consider. Then it is a dimensional equation. Now you go for non-dimensional equation. If you see here, we are having z star equals to 1 plus, so z star, if you go for 1 star control, so z by z0 and t star v0 by z0. If you put such ratios, already I told, if you want to reduce the things, you have to take care of that things, that always you have to go for ratios. And if you go for alpha equal to v0 square by g z0, so in this way you can represent the equation in a non-dimensional form, or you can reduce the dimension. So now you are having 3 variables, but all the variable does not have any dimension. All these variables are dimensionless variables. If you see z star, z has a dimension L and z0 also has dimension L. So L by L, no dimension. T star, if you consider there v0 into t, what is the dimension of a velocity? L by t to the power minus 1, and t dimension is t. So it will be L and z0 dimension will be L. So in this way, if you consider alpha v0 square, that means L square t to the power minus 2, and g is L t to the power minus 2 into L. So if you see that denominator and numerator both are cancelled out. So in this way you can create a dimensionless equation, and that also help you to reduction the number of variable you have to consider for a particular system. Previously what we have to do, we have to consider 5 variables for same kind of equation. Here we are considering only 3 variables for the same kind of equation having non-dimensional form. So in this way we can understand that non-dimensional form of the equation help us to reduction of the variable to be considered, or number of variables to be considered. Now what are the advantage? One advantage already during the discussion of dimensional equation and non-dimensional equation we understood, that is the reduction of number of variables. And here also you can see these two things are dimensional variable equation, but here you can see that non-dimensional equation of the variable. in the process, you understand that if we are considering non-dimensional equation or non-dimensionalization of a equation for a particular system, then size and shape of the system is not going to affect your understanding of the system. So independent of size and shape, at least if it is in the macro scale or in a one scale, then we can go for understanding of a particular system characteristics. So that is the biggest advantage of non-dimensionalization. And another advantage, you have to consider less number of variables in order to understand that particular system. These two advantages are very obvious. So if you see in this way, what are the benefits of non-dimensionalization? The reduction of parameter count is potentially a huge simplification, because if you reduce the number of variables, then what will happen? You have to do less calculation, number of equation you for to solve to get the value of variable is also going to be reduced. Consider an exhaustive lift measurement experiment where the effect of all parameters is to be determined. Let's assume that in this experiment we need to give each parameter 5 distinct values in order to adequately ascertain its effect on the lift. If we work with the 6-dimensional parameters in the system, then the number of possible parameter of combination and experiment runs about 56, equal to 15625. This is a very huge number. But if we work with the 3-dimensional parameter in a system, the number reduced to 125, which is more than a 100-fold reduction in effort. So you can understand a simple just reducing half number 6 to 3, the number of variables, the achievement with respect to computational time or calculation time is huge, and it's become very efficient. You have to solve very less number of equation or less number of calculation you have to perform. So non-dimensionalization is clearly a powerful technique for minimizing efforts as well as calculation effort, as well as theoretical approach. If somebody is doing simulation time or computational time, calculation time, experimental time will be reduced. The benefits of non-dimensional also extend to theoretical work, because if you do certain simulation work or certain modeling work, then as the number of variable will increase, you have to increase the number of equations, because that should be equal, otherwise you cannot get the solution for the variables. So when you can reduce the number of variables for particular system, then what will happen? Your solving equation will also be reduced drastically. That will help to increase the computational efficiency. Means it will reduce the computational time, computational approach will be much more efficient with respect to time. So, and also complexity will be reduced, the computational complexity. So deducing a statement such as statement 2 at outset, it can be useful to guide subsequent detailed analysis. So then you can go for subsequent detailed analysis, because it is also independent of size and shape of the system. Already you have done non-dimensionalization, and you will get more concise and more practical result with respect to independence of those kind of things. Here one theorem, this is from my book from Process Modeling for Steel Industry. That book you can see, and also directly you can take note from here on. So Buckingham pipe technique, it is actually a process to make the things dimensionless parameters. How to get that? There are different steps are there. It's an important method for determining dimensionless parameters. So step 1, identifying all the independent variables. These parameters generally include, these are the certain independent variables. Then determine total basic dimension involved. Reduce the dimension to force length time or mass length time. And suppose take the example of density. This is a FL T to the power 4, FL minus 4 T square. So in this way you can reduce, and then what will happen? you can now determine the total number of dimensionless parameters, that is pi terms, because pi itself is dimensionless, so we had the represented by pi terms. Using the Buckingham pi theorem, according to the theorem, the number of pi terms is equal to n minus k, where n is the total number of independent parameters involved determined in the step 1. So total number of independent parameter k is the total number of basic dimension involved in the form of MLT, is determined in the step 2. So now you can understand n minus k, the value you can understand, and this is the number of pi terms. That will be the number of non-dimensional parameter will be, or dimensionless parameter will be there. Means how many dimensionless number of parameter you can generate or you can find, that rule can be determined as per Buckingham pi technique. And how you calculate n? Go for step 1. How you calculate k? Go for step 2. And then n minus k will be the number of dimensionless parameter. So now we are going to discuss on step 4. Select k number of repeating parameters from the list of parameters determined in step 1. All the basic dimension must be present in this repeating parameter. Means that all that calculation should contain all the repeating parameters, but they cannot be dimensionless or have the same basic dimension. In other words, dimensionless parameters should not be found by repeating parameters. All the repeating parameters will be there, but they will not repeat themselves in particular one specific term. The pi terms are then found by multiplying the remaining parameters with the repeating parameter raised to a certain power. The exponent of the repeating parameters are determined such that pi terms are dimensionless. Once the pi terms are resolved, this concludes the dimensional analysis. Here, your dimensional analysis process is done. Now you have to correlate among the pi term, so that you have to formulate the experimental process. So which variable will be fixed, which variable will be vary, so that you can get the characteristic of the process. So suppose you can take an example of a flow of fluid in a circular pipe in the explanation of Buckingham pi theorem. Now we will take an example and we will try to understand how it is related to Buckingham pi technique, so that you can go for non-dimensional number and all those things. The parameters involved in this pipe flow problem, there is a pressure drop across the pipe length. When one fluid is flowing through a pipe, there should be a pressure gradient. That's why it is flowing, because that is the driving force. So that is del P, small p, and this is called the pressure drop across the pipe length. And there should be a pipe length is very important parameter. Otherwise, you cannot understand how long in lengthwise the fluid will be flowed. So then pipe diameter is very important. If you reduce the diameter, pressure will increase because the volume pressure relationship. And if you go for understanding other things, that fluid velocity. Now fluid property you have to understand. Fluid velocity, fluid density, fluid viscosity, and there should be a frictionless or friction, that part is come into play, and that is taken care by pipe surface roughness. The 7 parameters are involved in the problem. Now you identified there is a 7 parameters are involved in the problem, in that physical problem of the fluid flow. The flow of a fluid in a circular pipe. If we are going to apply the Buckingham pi technique in order to understand how much dimensional analysis we can do, then first step is find out the n. So that is the 7 parameters, and n equal to 7. How we are finding? We understand the process, physical process. So in order to get the n value, you should know the physical system or understanding of the physical behavior of the system. You have to understand. Then only you can identify what are the parameters you should consider to understand the problem or understand the behavior. After that, you can determine n by thinking all the variables by or considering all the variables same way. Then go for step 2. Here you are going to have certain basic dimension involved in the problem and which will be summarized in certain table. I just summarized here so that we can understand. So all the three basic dimension M, L and T means all the three basic dimension we represented. So K equals to 3 because only we tell that is non-repetitive basic dimension involved all the variables you have find out in the step 1. So pressure drop, what will be the MLT concept? ML T to the power minus 1, T to the power ML to the power minus 1 and T to the power minus 2. This is called pressure drop. And then pipe length L, already L, pipe diameter L is also length, and fluid velocity L T to the power minus 1, fluid density same way ML T to the power minus 3. In this way you can understand these are the variable pipe surface roughness and all those things are reduced to its primary or basic dimension. Now we are coming to step 3. So according to Buckingham pi theorem, the number of pi terms will be 4. How? Because n equals to 7 and the basic dimension number k equals to 3. Now it becomes 4. So according to what is the Buckingham pi theorem told us that if you are having the variables count which are involved to influence the problem of the physics or problem of the physical system, then if it is a n and if the number of basic dimension you can represent all variables, it is k, then n minus k will be your pi terms, mean dimensionless. So n minus k means 7 minus 3 equal to 4. Now we are going to step 4. Determine the form of pi terms. And now we have to find out what are the form of pi terms. For that we have to formulate certain mathematical equations and we have to calculate those equations, solve those equations and find out those things. So suppose the pipe diameter or fluid velocity and density as the repeating parameter. Thus pi terms are this. So we find out that in the process all the variables already told that you have to find out the repeating parameter and we want to reduce that repetitions. So we are going to find that diameter, velocity and density is the repeating parameter which involve all the variables to some extent. So that exponent of pi terms by 1, now we have this and repeating parameter, suppose their power will be guessed with a certain or represented with certain variables a1, b1, c1. So later on we have to find out these values a1, b1, c1, a2, b2, c2, all those are the powers of those repetitive variables, pipe diameter, velocity and density, rho. So if we go C series C1, C2, C3, so it is the value of power for the density for corresponding pi terms, pi 1, pi 2, pi 2, and pi 1, pi 2, pi 3, pi 4, those are the dimensionless terms. So in this way we can calculate. How to calculate? And then we have to go the exponent of the pi term and also we have to find out certain constant. Suppose rho p already we have a idea, this is a pressure drop, then L, mu, epsilon, those things we have to find out. Now for the pi 1 terms calculation, if we put this MLT kind of consideration, we just deduce all the variables, pipe diameter, fluid velocity, density into their basic or primary dimension. And in this process, if you deduce, then you will get the same equation. And in order to pi term to be dimensionless, what will happen? M should be 0, L should be m to the power 0, L to the power 0 and T to the power 0. All should be 0 term. Okay, I have to take one urgent call, so I am stopping here.